Good morning, everybody. We are, today is Friday, so this is kind of on your own. I skipped a section because I think the discriminant is like, there's a little art to it. So we're going to do a little section that you actually did on your first day as a group. It's kind of matching an equation with the parabola, so I thought it'd be a good little quick exercise for you. So our goal is sketching a parabola. So little backup, I wanted to kind of talk to you real quick about what, I don't want you to ever not know that when we talk about a parabola, we're talking about this scenario right here, and this is kind of from a family of what we call conic sections. Believe it or not, you have this double cone, and how you cut it creates these intersections of the plane and the cone. So if you cut it just perfectly, you get an exact circle. But if you tilt the plane a little bit, all of a sudden you get what we call an ellipse. And then this plane is like perfectly aligned with this angle. And so that's the only way you can create what we call a parabolic curve. So, man, I wish we had some dynamic software right here, but if we were to move this plane kind of backwards and forwards, you'd see that parabola get fatter, thinner. So it's kind of like that's the geometrical interpretation of making your A value bigger or smaller or negative. I don't know about negative. That's weird. Anyways, so that's pretty cool. And then a hyperbola is when you make that plane cut both of the and a hyperbola is just those things that have those branches that are kind of opposite of each other. All of these include like an x squared term. So that's why they're kind of grouped together in quadratic functions. But just thought I'd let you know. Hey, a real quick cool thing about an ellipse is there's a room in the Capitol building that what's cool about it is if you stand here and say, hey, how are you? All of the voices, all that energy goes away from you at all angles, but no matter what angle it goes, they all come back and they meet right at this spot. And these are called the foci of the ellipse. So you could be 80 feet away, 80 feet. And if you said good morning in a nice regular voice, 80 feet later you would hear it. You wouldn't hear the conversation happening from someone 20 feet away, but you would hear that 80 feet away. Whoa! So I know what you're thinking. What if you made a pool table that's elliptical, put the hole right here and put the ball right here. So no matter where you hit it, that ball would hit and go right in. Guess what? It's done. Look it up. Google elliptical pool table. Crazy. We're going to talk about parabolas. So, you know why we kind of get good at all this. And there's another way to look at parabolas, and that's using the foci and eccentricity. And these are like different terms on how to say how wide or narrow they are. So I just like to show you that anybody driving a car, you got your headlight. What it is you have what we call a parabolic mirror behind it, and then they put the bulb kind of sticking out right there. If you've ever had to change a bulb in a headlight, it's a lot easier than you think, but it kind of protrudes out from the mirror, and that's because that light hits there, and all the light is reflected parallel. So that's what's kind of cool about that. A satellite dish, same thing. All these waves are coming in and they hit, and then they're focused right at that focal point. I don't know where the focal point is on that one, but yeah, that's how those things work. So it's kind of worth looking at if you're into science, engineering, or just want to drive a car and kind of know. That's kind of cool. All right. The anatomy of a quadratic is very important. You guys showed me some great skills. The curve, believe it or not, is always the same. You're like, no, Mr. Sayers, you have wide ones, you have narrow ones. It's all in your perspective. If I walk away 10 feet, this parabola on my computer screen would look really skinny. If I got really close and I only looked at right here, it would look really wide. So please understand that that's kind of a cool thing. The middle line is called the axis of symmetry. We have, in this case, a vertex is called a minimum when it opens up. If it opened down, then it would be called a maximum. That brings up optimization, calculus. We're very interested in when things maximize. Hey, what's the maximum profit? What's the least amount of material that we need to use? Stuff like that. Those questions are answered by modeling it mathematically and finding where those points are. It's really cool. All right, this book calls these intercepts zeros. So when you're asked to find x-intercepts your entire life, and then on the SAT they say find the zeros, and you're like, what? So make sure you kind of understand when we're asking for those x values, we might say 0, we might say roots, we might say x-intercepts, and we might just say solutions, assuming that we're setting it equal to 0. Hey, today I told you it's about sketching. So how do you sketch this? Well, pretty darn easily. Sketch is pretty cool. If you have 1 point of this, ooh, that's pretty wild. Let's see if oh man. All right, that's okay. We can go here. If we had 1 point on this parabola, that would not be enough to know exactly where to draw this. Okay, so maybe we have this point. We have this point, and let's say we only have those 2 points. Well, we wouldn't know how to sketch it exactly, but if we knew that it opened up and we sketched something like this, that might be good enough. A lot of times in sketching, we just kind of want to have a general feel for what's happening. I know that's not what you've been taught. Where's the x-axis? Where's the y-intercept? All that stuff. I want you to relax a little bit and just get a feel for the parabola. Let Desmos get it exactly right. So today we're going to give you different parabolas, and if you can figure out the 2 zeros and you know it opens up, perfect. If you know, let's say, the vertex and the y-intercept, that's kind of enough, because you know it's going to turn right here at the vertex. So trust yourself on this. Let's do a few. So this is the only notes. I think there's a lot here. This is out of the book, but I changed a little bit because I thought it was a little bit confusing. So this is maybe something that you print off or you pause the video and check out. The first is, what if you're given the quadratic in what we call factored form? Well, man, you guys knocked it out of the park on Monday or Tuesday, when you said, hey, I think I can match these graphs, and you knew that these were going to be the roots. So that's P and Q. These are the little cool things. It sure makes sense that the vertex is going to be right in between that because there's symmetry. So how do you find the number in between? You find the average. All of a sudden you have the x coordinate of the vertex. Oh, that's pretty cool. So if you knew the x coordinate of the vertex, how would you find the y coordinate of the vertex? This notation is just saying plug that x value into the function. So in other words, if I know what the x value of the vertex is, I just plug it in right here and right here, evaluate, and find my y value. And then I'd have the vertex. There's a lot of good information there. All right. I don't like this row. It's a very special case of this row. And some of you were having trouble, I think, on number 13 when they gave you the vertex. Wow, I'd ask people, is any of those forms tell you the vertex? And a lot of people are saying, yeah, this one, because that's the x coordinate, that's the y coordinate. You need to thank your Algebra 2 teachers. They did a great job. If over a summer you could still remember that. So well done. So now use that information if you're given this equation, you already know the vertex. And then the A value is going to tell you if it opens up or down. This is called a sketch. That's good. I am okay with that. People are going to be nervous about how perfect it has to be. Sketching, sketch. It's inherent in the word. That person is sketchy. That means it's a little off. No, I don't know if that really works. But so sketch, just give me a ballpark figure. Hey, some cool stuff here. You know that I wish I would have written in A is positive, opens up. A is negative, opens down. Excuse me. Finally, the last one is our good old regular form. And believe it or not, this gives up a ton of information. You know, we developed the quadratic formula yesterday, and if I plug in my A, B, and C, I definitely get those 2 points. I'm going to throw out, we didn't talk about it that much yesterday. There's a little formula for the X coordinate of the vertex, which is also the axes of symmetry. Axes of symmetry is a line, so it has to have an equation, x equal. So negative b over 2a is in here, but we didn't really take time to talk about it, isolate it, so you're going to have to trust me on that one. Some people remember this from last year. Find the x coordinate, plug that into the equation to get the y coordinate. So if you have those skills, you might want to write those down to kind of have a reference. But let's do a few problems to see kind of what I'm talking about. All right, I circled the line sketch. I should also use the axis. Whoa, let's not do that. Okay, there we go. Let's do our good old pen. Intercepts only. So this is really letting you kind of relax a little bit. Hey, this is in factored form. That means I know I have a 0 or a root at -3, and I have 0 root at +1. So I'm going to go ahead and mark those. This is hard, the mouse. And then we got a +2, and the +2 means, hey, it's positive. It opens up. You know what's cool about this? This is exactly right. You're like, Mr. Sayers, how do you know it's exactly right? Do you see that there's nothing written on the y-axis? So I'm just I'm not stating anything. So if you don't know where the vertex is, don't write anything on the y-axis. A little cheating, but it's certainly correct. All right. So I'll bet you have a pretty good feel about this one. Maybe where the x-intercepts are, maybe it opens up or down, and that's what we're looking for. So a little quick sketch here. Obviously 1 and 2, so I put a 1 and a 2. It opens down, so I just kind of made that happen. That's it. You're like, come on, wait a minute, this is too easy. Well, maybe a different form, so let's look at it. So use the vertex, axis of symmetry, and y-intercept to graph. All right, so right away, what you want to be is like, which form is it? What information is it given me? This is called vertex form, so believe it or not, it's going to give you vertex. So if you're looking at this, I would say the vertex is -1, +4. -1, +4. So that's cool. I already have a point. I know it opens down. So believe it or not, I have a pretty good shot at sketching this already. But they kind of want this y-intercept, so like mark it on the y-axis. So you have to step it up just a little bit. So it opens down. So if I want to get the y-intercept, well, it happens when x is equal to 0. So just plug 0 into the function. 0 plus 1, 1. 1 squared, 1. 1 times -2. -2, -2 plus 4, +2. That, ladies and gentlemen, is our y-intercept. So I sketch -1, 4. I put a 2 right here, and I connect those dots. You're like, well, I don't know where it crosses the x-axis. Don't care. Don't care. Didn't ask for it. You just say it hits there and there. Now, if you want me to find the x-intercepts, might cost you a little bit more. But I would set this equal to 0, subtract 4, divide by -2, and take plus or minus square root and go from there. Determine the coordinates of the vertex. All right, once again, calm yourself down. Understand what form this is. This is not vertex form. I wish it was. We could complete the square and do all that, or we could use x equals -b over 2a. I put h because sometimes people associate the x coordinate of the vertex as the h. So, you know, just the more you can work back and forth. -b over 2a, certainly that. Plug it in, you get +2. So how do you find the y value? Just plug that sucker back in and evaluate. I got -7. So the coordinates of this bad boy, I don't know if I wrote it or not. Yeah, I did. To -7. Maybe you're waiting for the big ball to drop and like, okay, what's hard? You know, if you did a good job last year and you felt good about it, and it's coming back, life's good. All right, this is number 8 off your homework. I just wanted to do this one problem because for some reason there's a lot going on, so people kind of get confused. I asked you to do 8B and D, so you're gonna have to do D by yourself. So let's go through B. State the axes of symmetry. Maybe right away you're going, okay, what is that? All right, that's the vertex. That's the x coordinate of the vertex. So your first step, let's find x equals -b over 2a. Plug it in. I get 5/4. 5/4, that can't be right. It's got to be a whole number. It's math class. So trust your work. It's okay. It's just a beautiful number. 1.25 if you want. There you go. Part 2, find the coordinates of the vertex. So I'm going to plug 5/4 into the equation. I'm going to multiply, and I got -9/8. I apologize. It was late, and I'm pretty sure that's right. But I've been known to be wrong before. But the idea is correct. The idea. I'll model that. You show me the work, I'll give you an A all day long. All right. There's the vertex. Number 3, find the axes intercepts if they exist. So axes intercept, same thing as the 0, as the solutions, as the yeah. So how are we going to do that? That in this form, the best way is obviously to complete the square and have a lot more fun, but we have this tool called the quadratic function. So I plugged in -b plus or minus square root of b squared minus 4ac under the radical sign you see. Draw a line, and down below the product 2 times a will go. There's a little bit more to it. Quadratic, quadratic, crank it out. Give us the roots without a doubt. Bam. All right. If I plug this in correctly, I got 2 and 1/2. So I would say that they cross the x-axis at +2 and +1/2. Sketch the quadratic. That is feasible now that I have all that cool information. There's my 2, there's my 1/2, there's my 5/4 -9/8. There it's going up. Man, life's good. Hey, I would take a point off for this because you didn't write the numbers down. So, and if you miss the point that you drew, just make the point bigger or do something. So there you go. Good luck, everybody. That's the assignment that I'll be looking for. You'll find that there is very little work to show. 3 and 5 are just matching graphs. So that's all about you just kind of going through your brain and working it. Just let me know if you have trouble with it. Let me know, you can email me or chat or whatever and say, hey, can we practice that? Those are the skills I would like you to be good at. All right, under 20 minutes today. See you later.